Okay, so this is problem number 3 from 11K. And basically what we're asked to do is use tech to sketch these velocity graphs and find the total distance traveled. So in this one, where we just have cosine of t and it's 0 over 0 to 2 pi, that is quite literally just going to be the integral from 0 to pi over 2, because that's the word that I definitely said, of a of t dt. Yeah, cool. And that's going to find the area for me, which is just 1. Because there's no like moving back and forth between positive and negative here, we don't have to worry too much about it. So cool. That's the answer for that one. Yes. I'm like, is this our displacement? Okay. For this one, in this case, our bounds are a little bit different. And this time we're going to be moving back and forth, positive and negative, positive and negative. And if you wanted to break this up, you could, totally fine. You'd just be starting at pi over 6, and you'd end there at 1.407, which is probably some version of pi. Maybe not 3.306, that's kind of strange. But long and short of it is, if I wanted the distance traveled here, I would do the integral from pi over 6 to 3 pi over 2 of my function b of t. And if I just do dt right now, that's giving me displacement. That's giving me a negative number because I am more negative here than I am positive. If I want to get the actual thing, I would want the absolute value of this, and now it's saying 7.96. Now, if you were going to do this the long way, and this is just so you understand what it's going for, what you're going to do is you're going to use, boom, wow, all 3 of those. And you are going to get the integral from pi over 6 to this first thing, which is 0.140 or 1.407. Good word speak of b of t dt. And then you would add to that the integral from 1.407 all the way up to 3.306 of b of t dt. But in this case, because that section was negative, we want to have the absolute value bars. That's what gives us positive. Okay, so we're getting close to our 7.9. Then we would add to it, and again, this is overkill. You don't have to do this, but I want you to understand what we're doing. So we're going to go 3.324.5. So the integral from 3.306 to 4.405. Is that what it was? I just made that up. 548. I'm so far off. Oh my gosh. 8. And this time it can just be b of t dt, because I don't need to have the absolute values. And then the last one is just going to be that last little bit right there, which is going to be the integral from 5.4, or is it 458 or 548? Man, 548. What is wrong with me? 48. 548 up to 3 pi over 2 of the absolute value of e of t dt. And notice now, finally, we have the exact same answer. Okay, so long version of it. If you just use the absolute value bars, it would be fine, but I want you to understand, it's taking the first positive section, so like that positive section to that. And then it's going to add the negative section, and then it's going to add this positive section, and then it's going to add that negative section that's kind of hidden under that thing again. But please, for the love of Pete, just do this. So, moving along. C is this function, which is totally hidden by my face, which is not helpful. And in this case, we just have a positive and a negative section. But again, if you want the full thing, it would just be the integral of from 1 to 4.1. And this time I'm getting the bounds based on that of the absolute value of c of t dt. Voila, there is your final one. And then just because I was really excessive with b, we're not going to do the same thing. In this case, fun we could do the integral from 0 to 2.39 of 1 minus e t dt. And it's going to be mad because it doesn't have parentheses around that, so I'm going to put a parentheses around the function that I'm integrating. And it gives me that. And check it out. If I actually do the absolute value, it's going to be the exact same thing, except it's going to be positive because that whole thing is negative. Can you tell it's been a long day?